Hello, this is Mr. Ford, and today we're going to be looking at multiplication of operations that include a double by single digit factors. So what are these types of problems? These are problems you're going to see that are larger than your basic fact families, your multiples of 1 to 12. And they're going to have a factor that is single digit, so a factor between 1 and 9, or 0 and 9. And they're going to have a number that's larger than that. And we're going to focus on numbers larger than 12 when we're talking about double digits, but lesser, obviously, than 100 or triple digits. All right? A reminder, when we're talking about digits, we're also talking about place value. So single digit is equivalent to anything in the ones place value. Double digit is equivalent to anything in the tens place value. Triple digit is anything in the hundreds. And this obviously continues on into thousands and 10,000s and 100,000s and millions and so on and so forth. So when we're talking about digits, we're just talking about the value in terms of place value of the number that you're using. So let's start with a problem. So we're going to start off with 24 multiplied by 7. And here I can see that I have a double-digit number as my multiplicand and a single-digit number as my multiplier. So my two factors are here. And one way we can, or there's a few ways we can do this, so let's go through a couple of them. So one way is obviously we can draw groups. We can draw 24, I could draw 24 groups of 7 and then try and skip count them individually. The difficulty of that is that's going to take a long time. It's not very efficient. We can do it, but our risk for error, our risk for making a mistake increases the larger our factors get. If you're trying to draw them out and make groups with them, you're going to risk that you miscount, or you skip count incorrectly, or you double count a group, or you miss a group, and you end up with a completely different number, and you're not quite sure how you got there. So we're going to be focusing on some strategies that are a bit more efficient to solve this problem. So one of the first ways we can do this is we can find friendly factors. Okay, so friendly numbers that we know the product of that multiply by 7, which are lesser than our multiplicand, lesser than 24. And I know, I feel really confident in multiplying 7 multiplied by 4. And I know that if I do that, I'm left with a multiplicand of 20. So let's break this down into some friendly factors. So 24 I can easily break down into 10, 10, and 4. So this process means I'm going to be solving 3 separate operations, and at the end we're going to actually add the products together. So I know anything multiplied by 10 increases the place value of the other factor by a factor of 10. So 7 multiplied by 10 equals 70. That helps me immediately with my second operation. 10 multiplied by 7 equals 70. And I know that 4 multiplied by 7 equals 28. So now that we have these three products, remember, we're not stopping here because we're not trying to find 10 multiplied by 7 or 4 multiplied by 7. We're trying to find 24 multiplied by 7. And so what we're going to do is we're going to add these numbers together. So I know that 70 and 70 is 140. And I know that 140 add 28 is 168. Therefore, we can look and see that the factors of 24 multiplied by 7 equal a product of 168. So that's one way we can do this, by breaking up larger factors that we're not confident with into lesser factors that we can then add back together later. That's one method. I'm going to try a different one. This time, I'm going to write the same problem, but I'm going to rewrite it vertically. So we're going to start off, unlike reading, when we start off with a vertical math problem in terms of addition or subtraction or multiplication, you'll be starting on the rightmost column. And for multiplication, we're going to start where we have 4 multiplied by 7. Well, we know that. We did it over here. It's 28. The 8 is in the ones column. So this here, this is the ones column. So we know that the 8 out of 28 is in the ones. It stays there. The 2, however, needs to get regrouped. You might also hear regrouped called carryover, right? It gets regrouped or it gets carried to the tens column. Well, that's not some crazy work of magic, all right? The 2 gets placed over there because this is 28, but we're not done with this 2 yet, so we can't put it down here in the answer block. We have to regroup it up here because we're going to need to use that later on. After you've done your first one, unlike addition, where now 4 and 7, we've dealt with them, they're done with, in multiplication, you need to multiply each portion of the problem by each other digit. So 7, we multiplied it by 4, we got 28. Now we need to multiply 7 by 2. And we know that 7 multiplied by 2 is 14. There's no other number up here. There's nothing here in our hundreds place. And so this time around, the 1 from 14, it's allowed to be put into the answer block because there's nothing else for us to be multiplying. It does not get regrouped. We have 14, but before we write 14, we have to do something with this 2. So now that we've multiplied 2 by 7, we're going to add that other 2. So 14 add 2, 16. And we end up with a product of 168. The same product that we got over here. This has, again, been Mr. Ford, and today we have been talking about double-digit by single-digit multiplication.